For centuries, we've pondered the universe's ultimate fate. But what if the void beyond its collapse isn't empty, but a primordial crucible, already forging realities we're simply not meant to comprehend yet? From the infinitesimal spark of the Big Bang, our universe has expanded, evolved, and illuminated the cosmic stage for nearly 13.8 billion years. We look out into the night sky, captivated by the twinkling lights of distant stars and galaxies, each a beacon in an unimaginably vast tapestry. For centuries, humanity has grappled with profound questions. How did it all begin? What is our place within this grand design? But as our scientific instruments become more powerful, peering ever deeper into space and time, a new, equally profound and perhaps unsettling question emerges from the shadow of the unknown. What happens after the universe ends? This isn't just idle speculation. Modern cosmology, armed with data from telescopes like Hubble and the James Webb, tells us that our universe isn't static. It's expanding, and not just expanding, but accelerating its expansion. This acceleration is driven by a mysterious force we call dark energy, which currently makes up about 68% of the universe's total energy density. It's this enigmatic force that holds the key to the universe's ultimate fate, dictating whether it will fade, tear, or perhaps even collapse back in on itself. Understanding dark energy is paramount to predicting the final act of cosmic existence, and the after of that final act is where the true mystery lies, pushing the boundaries of our imagination and scientific inquiry. It forces us to confront not just the death of stars and galaxies, but the very fabric of reality itself.
The fate of the universe hinges on a cosmic tug-of-war between gravity, which pulls everything together, and dark energy, which pushes everything apart. Current observations overwhelmingly suggest that dark energy is winning, leading to two primary, chilling scenarios for the universe's ultimate demise. The first, and currently most widely accepted, is the Big Freeze, or heat death. Imagine a universe where stars burn out, their nuclear fuel exhausted, leaving behind stellar remnants, white dwarfs, neutron stars, and black holes. Over unimaginably vast timescales, these black holes themselves would slowly evaporate through Hawking radiation, leaving nothing but an incredibly dilute soup of fundamental particles and photons, spread across an endlessly expanding, cold, dark, and empty void. Entropy, the measure of disorder, would reach its maximum, and no further energy could be exchanged or work performed. The universe would simply run out of steam, a final, quiet whimper. The second possibility, even more dramatic, is the Big Rip. If dark energy's repulsive force continues to strengthen or remains constant, it could eventually overcome gravity at all scales. First, galaxies would be torn apart. Then, individual stars and planets would be ripped from their orbits. Eventually, the very atoms themselves would be separated into elementary particles. Space itself would expand so violently that it would overcome all fundamental forces, literally tearing apart everything down to the quantum level. In this scenario, after doesn't just mean empty space. It means a universe where even the concept of matter and structure has ceased to exist, an ultimate violent shredding of all reality.
While the Big Freeze and Big Rip are currently favored, the universe holds other, perhaps even stranger, possibilities for its end and what might follow. One classic theory, the Big Crunch, posits that if dark energy eventually weakens or gravity proves dominant, the universe's expansion could reverse. Galaxies would begin to rush towards each other, space itself would contract, and all matter would collapse into an incredibly hot, dense singularity, much like the inverse of the Big Bang. But what then? The Big Bounce theory suggests this singularity isn't an end, but a reset, a cosmic rebound into a new Big Bang, initiating a new universe, perhaps with different physical laws. This would imply an eternal cycle of death and rebirth for the cosmos, a universe without true beginning or end, merely an endless series of transformations. Even more speculatively, the concept of after might extend beyond the boundaries of our own universe entirely. What if our universe is just one bubble in an infinite, multidimensional multiverse?
In some multiverse theories, the end of our universe, be it a freeze or a rip, might simply be a local event within a larger cosmic ocean. New universes could constantly fizz into existence through quantum fluctuations in a primordial energy field, leading to an endless proliferation of realities. This shifts the after from a singular event to a continuous process, where every end is merely a beginning somewhere else. A tantalizing thought that challenges our conventional understanding of space, time, and existence itself.
The profound questions about the universe's end and the after are not confined to philosophical debate. They drive cutting-edge space research, pushing the boundaries of human knowledge. Missions like the James Webb Space Telescope and forthcoming projects like Euclid and the Nancy Grace Roman Space Telescope are meticulously mapping the large-scale structure of the universe, measuring the expansion rate with unprecedented precision, and observing the most distant galaxies to understand the evolution of dark energy. On Earth, particle accelerators like the Large Hadron Collider delve into the fundamental nature of matter and forces, seeking to uncover the building blocks and rules that govern cosmic destiny. Every data point, every observation, every theoretical model brings us closer to painting a clearer picture of our cosmic future. Yet, these are questions that transcend pure science. They touch upon our deepest existential anxieties and hopes. To ponder the end of the universe is to confront the transient nature of all things, including ourselves. It's a reminder of the fragility and preciousness of existence, and the incredible privilege we have to witness and study this grand cosmic drama. The after may forever remain beyond our direct observation, a realm of ultimate speculation. But the very act of asking, of searching, of reaching out into the dark, embodies the indomitable spirit of human curiosity. It is in this relentless pursuit of knowledge, even about the unknowable, that we define our place, not just within the universe, but within the timeless quest for understanding.
Subscribe to the channel and hit the bell icon for more amazing videos.